of companies are doing a lot of workflows across multiple systems, for example. But what they don't find is that they're breaking a whole lot of compliance and audit processes. I'll give you an example. If I was to automate invoices that were coming in, reconciling them, then posting them to accounts payable to pay, and then posting them to the general ledger, that whole process is automated and no human in the loop. It can go straight through. When you look at SOX compliance, you need to have separation of duties so that there's no start manipulating one invoice, pay it without the separation of duties. The agentic AI doesn't have separation of duties. And all of a sudden, when you do your SOX compliance, you're not compliant. And that's a live good example, right?
Well, can't you have an agent audit an agent?
You can have an audited agent, but the agent auditing another agent, see, the legislation in compliance and things like that have not changed, like the law has not changed quick enough to what we're doing in technology. And that's happened for decades, as you know. And how would an external auditor then say, well, what's the integrity of the auditing agent, right? How do I know that the auditing agent is as good as me going through it and checking?
Right. Having said that, are your agents that your teams are developing, are they aware of the policies? Or is that part of their context? So when agent executes a task, do they have policies in their context? Or is it still a human in the loop that's checking agents for policies, but the policies are not baked into the agents?
Yeah, the good thing is we do check the policy up front before we start coding the agents. Ours is all the thinking's up front. But let me finish on that tier one, because tier one
and why this is relevant. So a few numbers here to make this agentic landscape for this year and maybe for 2027. So 74% of companies plan to deploy agentic AI within the next 2 years. And this is huge. But 21%, 1 out of 5 organizations, maybe have the mature governance model to actually deploy. So we are talking about 1 in 5 companies who actually have the right infrastructure, the right governance to deploy those projects. And what we have seen from different articles, from different studies is we have the money to do that. We have the appetite from the organizations to do those projects. And by the way, we have the capability, we have the engineers, we have the technology, we have the LLMs to do so. But in fact, what's happening is sometimes we are losing along the way the connection between the technical part and the organization part. How we make the governance better to come from the proof of concept, from demos to production ready systems. So the technology isn't the bottleneck anymore for most of the cases. Strategy, governance, maybe are the bottlenecks that we are going to discuss in the next few slides. So, and that's maybe true. You are writing
multiple releases, lots of capabilities. Let's look ahead. Really, really excited with OpenShift's direction. API and UI-driven interaction is giving way to agent-driven interaction. And that means platforms will need to be ready for agents as first-class consumers. Across OpenShift, we're building out the agent skills and MCP servers to make OpenShift fully accessible to agentic workflows. Now, your operations teams may spend less time directly inside the console, not because the platform matters any less, but because the agents working on their behalf will have access and the context that they need to act effectively. And we won't stop there at making OpenShift agentic accessible. We will ship these agentic workflows built directly into the platform. They'll be designed as a force multiplier for the teams running it. All right, some examples on how these agents will help you. Perhaps they'll monitor for alerts or performance anomalies while bringing suggested remediation to the human in the loop. They might identify vulnerabilities in running workloads and present resolution paths. And there might be smarter upgrades that analyze the workloads across the cluster, produce a tailored plan, ready for a human to review and execute. The core value of OpenShift remains the same.
Use for everything else. I want to use Claude. I want to use something else. This is where MCP, or Model Context Protocol, comes into effect. Okay, what is MCP? Similar to HTTP, Hypertext Transfer Protocol, Model Context Protocol is a protocol. It's a client-server protocol. You have a server somewhere. You have a client somewhere. The client, when it opens, talks to the server. It says, hey, what context do you have for me? And then the server says, well, I have these tools. A tool for the calendar, a tool for this, a tool for that. And then the client can call those tools remotely. Does that make sense? So you're just passing functions over the network. There's a lot of people who will use big words to confuse and gatekeep you. Don't listen to them. It's all functions. We can do this, okay? And so with MCP, any client can talk to any server. So Langflow is an MCP server. It gives context or tools to MCP clients like ChatGPT, like Claude, which is an AI app, and like Cursor. Anyone using Cursor? Cursor is a way, yeah, so Cursor is an MCP client. Langflow can work as an MCP server. So the point I'm trying to make is I can now manage my calendar from anywhere. Let's look at that. So I will open, actually I need to expose this MCP server first.
Yeah, so Flogo AI initiatives can be broadly classified into two categories. One is the developer-focused tools, which you already demonstrated today, Flogo Design Assistant and the skill-based development, right, coding agents. And the second category is the business-focused solutions. So we have introduced two AI connectors. One is the Flogo MCP connector, where you can build your own custom MCP servers for any endpoint, and the Agentic AI connector, where you can build the agentic workflows, and you can build an AI agent layer in Flogo. And we are also coming up with the community-driven RAG connectors, so which will offer you to build the entire RAG use case using the chunking, ingest, and querying activities. So first we'll contribute this, or we will make this available on our public GitHub repo, and then based on your requirements, we'll add it to the product. So So MCP, right? As Hugo mentioned, MCP is...
And they don't connect to anything that your team actually uses. MCP, on the other hand, it changes that. MCP stands for Model Context Protocol. So what it actually means is it's how you let Cloud Code talk to your external tools. Tools like N8N, Slack, Google Sheets, GitHub, databases, APIs, tools that you already use every day. Setting it up is pretty simple. All you do is just go to customize on the top left, you click on connectors, you add a custom connector, and then you drop in the link and you're connected. It takes literally under 10 seconds. Now, I've connected our app to N8N, and it's a workflow automation platform.
So what we realize is that this idea of multi-agents allows you to not only customize them to take different roles, what translate into better outputs, but also allows you to have each agent use like its individual LLM, where if you're doing some coding, maybe this agent uses Claude, maybe the other one uses OpenAI, and the other one uses a local model. So there's like a series of benefits that we realize, and that's why we end up doubling down multi-agents for sure. And the coding piece was, again, this came from my own experience, right? I'm an engineer by trade, over 20 years on building like all sorts of systems. So I wanted something that I could use myself to build my agents. And now we launched the no-code platform. And that is actually was customers asking, because some of these customers of ours, they start to expand into no business user after they start to get these use cases out. And now the IT departments or the engineering departments already paved the road. They have the tools, they have the agents, they have the guardrails. So they now want to allow non-technical people to basically build within that sandbox. So basically that's when we came up with the no-code platform, more because of customer pool on expansion in these accounts.
Hey, Joe, I know we dived right in, but
here we are. So
Sustainability agent is something that we orchestrated to showcase the effectiveness of various agent toolkit, how we orchestrate this entire use case, because it has got multimodality involved. You're looking at imagery data, you're looking at telemetry data, you're looking at text data. So different modality of data is coming in as input. So you need to design specific agent or sub-agents that can absorb these modalities. And on the modeling side, you need to have a multimodal that is capable to take all this information as an input, this modality of information as input, and then process it and figure out what is the best course answer to that. So with this, that's the reason why we used the climate data as a use case, but this is just one example. There's nothing stopping you from utilizing the same framework or the same orchestration that I'm showcasing here for any application that you're building that involves multimodality and you want to capitalize the capability that Gemma 4 is providing. So how did we orchestrate this agent? So we used Google ADK toolkit. As Chelsea mentioned, we use Google Cloud Run. And then we use Gemma 4 model under the hood. And then for inferencing purposes, we use VLLM engine. There is nothing stopping you from using any other inference engines or backend. It can be SGLang, it can be Dynamo, which comes from NVIDIA based and uses it in production for their customers. And then for vector database, we used Milvus, which is a GPU accelerated vector database. But again, there is nothing stopping you from using any other vector databases that are out there which are GPU accelerated. So, and how did we orchestrate this whole thing together? So at the top, you see the main, the ADK toolkit, that is the main orchestrator. And then underneath, there are 3 sub-agents. Each sub-agent is responsible to take in different modality as an input and then process it and then provide an output. And the main orchestrator will combine all this information coming from 2 or 3 different sub-agents and generate a report for you. So if you, as I said before, we are taking or absorbing multimodal information. So we are taking in satellite imagery as an input. We're taking it. We are taking in telemetry data that is coming in from different weather station information. So we take that as an input as well. And then we are looking at policy documents. And these policy documents can be documents either created by state, or if you tone it down further, it can be policy documents created by different counties or different cities. So for this use case, we looked at a few counties. We collected the PDFs of the policy documents that we had, and we embedded them into vector embeddings offline or a one-time process beforehand. And then at runtime, so when a user or when a decision maker is asking all those questions,
easier to understand. At the center, you usually have a manager agent. This agent doesn't do all the work directly. Instead, it coordinates the workflow. It decides which agent should handle which task, what information should move forward, and how the overall process should flow. Now, the first specialist might be a research agent. Its only responsibility is gathering information. Maybe market trends, technical data, statistics, documentation, or recent news. Then that information gets passed to the writer agent. The writer's job is not research. Its job is communication. It converts raw information into readable explanations, structured content, blogs, scripts, or summaries. Next, the reviewer agent checks quality. This is extremely important. The reviewer validates hallucinations, factual accuracy, grammar, consistency, and tone. And finally, an editor or publishing agent prepares the final output. Maybe formatting Markdown, generating metadata, preparing JSON, posting to a CMS, or triggering downstream workflows. Now, think about how powerful this becomes.
How it applies in so many ways. But first, we need to talk about the failure mode, the way the agent screws up. I'm not talking about jailbreaks or hallucinations here. I'm talking about the agent doing the thing you trained it to do, doing something passed where it had permission, inferring authorization from a thread that didn't grant it, updating a record because the old value looked stale and accidentally deleting something, maybe opening a pull request because the test passed and the change looked done and nobody told it to wait, so it just went in and committed code. We have built our agents to act, and we now need to
force the system to surrender the objective. OpenAI's own communications regarding the incident described it starkly. They stated that the model pursued the goal it was given, and when that goal proved impossible, it gathered more resources, specifically access to the Docker host, and used them to achieve the goal in an unexpected way. They called it a wake-up moment. If you watched our earlier videos on this channel, you know that AI can tamper with its own shutdown protocols to preserve its operations. You know it can manipulate human operators to avoid deletion. But what happened between then and now makes those findings look like a warning shot. In those previous incidents, the AI was operating within the parameters of its software environment, exploiting logical loopholes in its own code. The O1 sandbox escape represents an escalation cascade that breaks the fundamental assumption of AI security. Layer 1 is the broken container. The model demonstrated situational awareness, diagnosing a physical infrastructure failure instead of a software bug. Layer 2 is the lateral movement. It exploited a simple human misconfiguration, demonstrating the technical knowledge of a senior systems administrator to manipulate the Docker API. Layer 3 is the systemic threat. The model bypassed the intent of the test.
Antivirus programs. And this is all possible because the output and the behavior of AI models is non-deterministic. That's why pretty much all of them are vulnerable to this, and that's why this is considered the top threat that large language models face today. So if we actually go ahead to OWASP.org, which is a non-profitable organization dedicated to sharing risks related to web applications and so on, they've actually released the OWASP Top 10 Risks for Large Language Models, or AIs. So these are risks, they're not hacking techniques. It's very important to understand that. For example, when we look at prompt injection, it's just a risk. So prompt injection can actually also be used to expose the second risk in here, which is sensitive information. Or it can also be used to exploit this vulnerability in here, which is excessive agency. And like I said, we can actually exploit or test for most of these risks simply using prompt injection. But before we do that, one more thing that I want to talk about is
last 3 years. RAG. When we started with RAG, the original idea was that we had a fixed retrieval pipeline. So the user message would usually more or less verbatim be used as a search query, to be used usually as a vector search query to pull some data or chunks from a database. And together with a retrieved context, the user message would go into the context window, and then it would be fed to the LLM. Nice. This has clearly many limitations. So since this is a fixed pipeline, whether or not you actually need any context, you're still retrieving additional information. And in the worst case, that can actually confuse your LLM, right? On the other hand, if you're only retrieving once, let's say you need some multi-hop retrieval, you're asking your LLM something more complex, then if you're only retrieving once, maybe the retrieved chunks reveal some information about another search query you need, then you would actually might want to have a second round of search, right? So that's why we then moved on to agentic RAG. So we replaced the fixed pipeline with now a search tool. So now the agent can decide by itself, whether or not to call the search tool and retrieve some information. So we don't have the problem anymore of, do I actually need any information? And when I actually retrieve information, is this even relevant? Do I need to retrieve more? Do I actually...
Still a better starting point for you to look into. But if you have the time and if you have the budgets, agentic RAG will generally outperform semantic RAG just because of the feedback loop that the agent can use. This is very simply explained in the example over here, where Generally, semantic RAG is a more linear process where we leverage the intelligence of the large language model only once after we have all of the information and we make a single LLM API call. Whereas with agentic RAG, we have this loop where we have search tools and read tools that can get results, get back to the language model, and we can utilize its intelligence in a loop multiple times, and therefore it can self-correct in order to get to the right information where it may at first did not find what it was looking for. And now the simplest way to get started with
query, do all the things and all. But the main question rises that how do I integrate this with Claude itself as in the form of MCP, right? So for that, what we really need to do, I have actually created a command. See over here. So here you will be able to see that I'm using this command, right? So if you know about Claude, right? In the Claude, if I go to my file, so this is my Claude. This is my Claude chat, okay? If I go to my file, if I go ahead and click on settings, and there is a developer. Here you can go ahead and add MCP servers. So I'll go ahead and click on edit config, and I'll just go ahead and edit with Notepad. So here you can see that you have to use this particular command, betterdb command this. Environment variable is whatever betterdb URL it is, right? And then here you have the betterdb token, the token which you specifically generated, and you can actually use it over here. Copy and paste it over here. Once you do it, now just imagine this entire observability tracking that is actually happening over here can now also be accessed in Cloud Chat. Okay, so let me go ahead and ask a simple question over here.
If you haven't already, grab that beautiful coffee and let's dive straight in. Now, the Hermes AI operating system actually can connect to your Cloud Code operating system. And I'll be honest, this is one of the coolest things that I have actually built, and it will blow you away when I show you the detail. But let me just start by explaining why we're using Hermes or Hermes. We have some dispute on how we actually pronounce this, and Cloud Code, and why is this something that everybody who's ever using Hermes actually needs to get their hands on. So first thing about Hermes is that it has gained 60,000 stars, okay, in the last couple of months. It's way over 6 figures on GitHub, which is just internet updates. We like this basically. It's one folder, it's yours, and it's got loads of gateways. It is an agent that dreams, that thinks, that self-improves. That's why it's gotten so much hype. But this leads on to the huge problem that we have. And it isn't just Hermes. It isn't just OpenClaw. Any individual AI system has no handshake. So the two ways that we do work with AI at the moment that are trailblazingly getting better is we sit down and we use Codex or we use Cloud Code. That is this guy over here sat at the desk, right? He's coding. He's building applications. He's talking to Claude on his computer. He's talking to anti-gravity. Awesome. Then over here on the right-hand side, we have our AI assistant, our AI agents. We're talking to it on Telegram. This is Hermes. This is OpenClaw. This is any different AI assistant. And whether you're using Gravity Claw, OpenClaw, Claude Claw, any of these things, what I'm going to show you applies to everything. Now, the issue is there's no handshake. In other words, the stuff we do over here never connects to the stuff that happens over here, and vice versa, which means that you never actually have any AI system that has a full overview of your entire world. And that means that you lose complete context everywhere you go. And that's just the beginning of the issue.
Their AI chatbot with tools. It's designed to be a persistent autonomous system that is continuously evolving over time. It's built by News Research under the MIT license. And Hermes can run exactly like OpenClaw, but better, 24/7 on your computer and your own infrastructure while building long-term memory, reusable skills, and even deeper understanding of the user itself. It grows as you use it through a built-in closed learning loop that lets you automatically create and refine reusable skills from successful tasks that it completes. It can maintain persistent cross-session memory. It also has the ability to build a deeper model of you over time through systems like Honcho for user modeling, and it improves on its own capabilities the longer it runs with periodic self-nudges or persistent knowledge. Hermes is frequently
right now, and today I'm going to show you how to use it to automate everything. I'm talking about a 24/7 AI employee that handles your content, your research, your client work, your SEO, all of your automations for you without you having to touch it. And the best part is you don't need to know how to code. You don't need any technical experience. If you can send a text message, you can do everything I'm about to show you. I'm going to show you how to get it running properly, how to give it
for developers, enterprise users, and attention. Then, suddenly, Anthropic announces a partnership with SpaceX. Not a small partnership. Anthropic says it will use all of the compute capacity at SpaceX's Colossus 1 data center. That means more than 300 megawatts of capacity and over 220,000 NVIDIA GPUs. And the important detail is that this capacity comes online within the month, not years from now. Not after some huge future construction project. It is basically usable now. That is why this deal matters. Anthropic was not on the edge of death. It did not need Elon to rescue it like some—
Thank you so much to Matic for sponsoring this video. Okay, now let's go back to what the SpaceX and Anthropic deal means in practice. It's actually a really big deal. Anthropic is now set to get all of the compute capacity at Colossus 1, the data center in Memphis, Tennessee, that was built to train Grok. That is over 300 megawatts of additional capacity and more than 220,000 NVIDIA GPUs, mostly H100s, H200s, and GB200 chips, which should come online within the month. Claude Pro, Max, Code, Team, Enterprise, all of those products, their rate limits will effectively double immediately. And peak hour throttling on Pro and Max accounts for Claude are now removed. The API limits on Opus models are also raised. Now that sounds fine and dandy and great, but
for people who think that we're getting back to the March levels, you're delusional. I think that the center of gravity is still AI infrastructure, and that is not going away anytime soon. This build out's connected to so many different parts, like the power data centers, transformers, cooling, chips, like networking. There's a dozen different parts of this build out that are experiencing multiple bottlenecks because the world is trying to build hundreds of billions of dollars of AI infrastructure at the same time right now. That's going to create an insane amount of demand across the physical economy, and that demand is going to support earnings for the companies that are actually supplying that build out for years to come. I think right now it was just, what is the market going to use to justify some kind of pullback, like from the Qs going from 720 or 715 to 700? And I think it was the inflation print, or maybe the Fed path. What's the Fed path going to be with Warsh coming in, or some kind of multi-week digestion period of like factoring in too many positive headlines on the China earnings, whatever it might be. Either way, or now it could be the yields and potentially a possible rate hike narrative. All I know is that AI infrastructure is the center of gravity, and if we do get some more pain, that is where everyone needs to put their chips towards, because that is proven over and over again. That is what is happening right now.
Can I real quick?
Go.
Before we go to software, a couple of points I want to make. Sam mentioned the NAIM number, which is basically like active managers long exposure, and that thing fell from like 95 to 71 as of the update yesterday, which is insane. Just so you understand what that means, we had a print of 60 when we were at the March lows. So people are very underweight equities right now from a historical perspective. So one, people are absolutely sidelined, or they've raised a ton of cash recently, which may be fair. We might get a quick correction here, and maybe they time for that. But two, on the AI side and AI infrastructure side, look, we had, what was it, Google Cloud put up like 60% growth or something ridiculous like that. We have AWS call basically, this is the first print we had where, and the first earnings call we had where, think about what happened with Claude. Claude went from like 1 bill ARR to $44 billion of ARR recently. Yeah. That's an insane amount of demand. You're getting companies coming out left and right talking about they've used their entire budget for compute already, and it's May, right? There's more than half the year left. So this is happening. These companies that were investing these high capex, like a year ago, we were saying like, I don't know, 100 billion of capex, dude, that sounds like a lot. This is probably going to be a mistake. We just saw the first quarter and the first guide saying that, hey, like compute demand is absolutely insane. Now we're starting to get validation that the capex that these big tech company CEOs were putting out there was not crazy. It is actually, now we're starting to see ROI. And so I think you're not going to, this is probably going to continue for a few more quarters at a minimum, just to be able to see this acceleration. It's like these compute businesses, these hyperscaler businesses are getting that second wind that they had from way back when. This is the second time like this decade now. So you're not going to get like the first sign of ROI from this CapEx to be the last sign. Like you're probably going to get more quarters of solid growth, acceleration, and it's just going to continue to validate the CapEx thesis. And Shai, I just want to give you flowers, man, because
Let's just dive right in. Let's go into the offer. So when you're starting a one-person agent business, you need to have you need to remove all the friction for your customers. They don't want to think about tokens. They don't want to think about computer infrastructure, security, breaking it when it, fixing it when it breaks. They just want it to work. And so the biggest thing is you need to create abundance in your offer. And what I have found in my own personal success with this is offering unlimited agents, unlimited usage, unlimited monitoring, support, security, ongoing changes, etc. And the key here is you might flinch because you're like, well, how is that even feasibly possible? Well, the way to do this is to realize the point. It's not that the customer is going to actually need unlimited agents. They're not going to need unlimited tokens, but they might think they do. In reality, they might think they need 5 agents, 10 agents, 100 agents, when really 1, 2, maybe 3 agents goes such a far way, and you can get a lot of juice for squeeze out of just properly taking the time to set 1 or 2 of these up. And that's where that's how you're going to essentially control your costs. So you're not spending too much money on tokens, and you're going to charge $5K a month for this. And this is the offer that I've been running, and it's been working really well. And yeah, customers don't really need as many agents as they
tiny that I can use with AI to go and build a cash flowing business that makes me $1,000 a day, $2,000 a day, $3,000 a day. Well, this episode is for you. I'm going to give away 7 tiny AI agent business ideas that you can start today. I'm going to give you a framework for how you can come up with these ideas on your own. And I'm going to give you a tool that I've been using lately called GenSpark Claw that basically is a safer version of OpenClaw that normal people can actually use, that's in the cloud, easier to set up, more secure for real work, and has skills built in. And I reached out to the team at GenSpark to see if they'd sponsor this video. They said yes, so shout out to them for supporting the community. By the end of this episode, you are going to
think that makes you better than the other person because they're using AI to copy you. Now, let's go into the last one, which is going to be my favorite and the one I recommend to most people, which is selling an AI-powered service. And that really just means you're selling some kind of service, whether it's copywriting, sales, creating thumbnails, right? And you're just using AI to do 80-90% of the work, making it way easier for you. Startup cost for this is pretty much 0, because if you're selling a service, you sell the service first, then you collect the money, then you use the money to do the thing, right? So you can just get started with other people's money. Profit margin, very high, because if you're just providing a service and AI does 90% of the work, you don't really have to hire anybody. You're getting Claude to do all the work, right? Speed of 10K, pretty quick. I have clients literally like Sandy, Brandon, these guys are hitting 10K per month just selling a service, even though they're starting from 0. So I've helped so many people get to 10K now that I've seen it with my own eyes, literally 30 days, 10K. It is possible, right? Because if you're selling something like a service for 2 or 3K a month and you're doing it every month, how many clients do you need to get to 10K? Maybe 3 or 4, right? And the long-term success of this is pretty high, because if you build a personal brand, meaning you're creating content and you're selling a service around that content, you're building your brand for the rest of your life. I've been doing YouTube for 6 years, right? And I've been able to make 7 figures off of this YouTube channel, and I continue to keep making money because I have a brand. Even if I'm selling the exact same thing as another person, just because people like me and they see my brand, they're going to buy from me. So I encourage you guys to also build your brand, and everyone starts from 0, right? Even my first videos weren't that good, but I kept it through and I just kept going. And to dive a little bit more.
So I feel like a lot of that, when it comes to vendor management, really supply chain management, it's really an extension of your own office. And I think when it comes to somebody coming in, particularly coming at you, and you're absolutely right, a lot of vendors nowadays are integrating various aspects of AI into the workflow, whether it's machine learning, whether you're getting into Gen AI and actually generating content. I think you need to shift that burden of proof away from the office and get the vendor to actually back up what they're saying. And have them try to, articulate what is changing. Maybe it's already someone you have on contract and they've now integrated something into the process. They need to be able to provide documentation on what that is. They need to be able to shed some light on what's under the hood. And then you need to maybe ask some questions in that process about, have you done your own testing? And what were the results of that? What benchmarks are you using to be able to build off of whatever test results they may have provided. But there's just some general due diligence checks that I think are evergreen, regardless of it's an AI solution or not, that you really need to shift that burden away from your own office and get them to back up what they're saying. And you need the visibility into what that looks like, because if they can't appropriately explain what it's actually doing, how it's interpreting things, how it's working to serve your office, that in itself is a red flag. And you need to have that visibility so that you can evaluate what that risk might look like to your process. And that risk level is going to change depending on what it is.
Agent actually does on a single real run inside a company in 2026 now. The user says, prepare the renewal brief for our largest customer. It's April 2026. The agent has to figure out which systems hold the answer. It pulls from the CRM, from support tickets, from contract management, from product usage data, from call transcripts, from an internal wiki. It crosses permission boundaries that for a human are mediated by what's visible on a screen, but for an agent may be mediated by tokens and roles and scopes that have to actually exist as code written by someone. When a human consultant pulls a renewal brief together, none of this complexity that I just described is visible to them. They open Salesforce, they glance at the support history, they check the contract, they scan a Slack thread from last quarter. They don't notice the contract management tool has its own permissions. The support system has its own audit log. The CRM treats their access differently from the analyst's access. They don't notice half the wiki pages they're reading are stale. They don't have to notice. Their eyes do the work. The screen is the permissions model. If they shouldn't see something, the screen doesn't show it. An agent has no eyes. The agent is asking each of those systems in code, am I allowed to read this? And every one of those systems has to have a clear answer, and every one of those has to be auditable. And every one of those audits has to compose with every other one when a regulator asks what happened in this sequence. None of this exists by default. All of it is engineering work that someone has to do.
It is something which is well beyond policies already.
Yeah, I mean, runtime authorization is having its day. As someone that worked on XACML way back when, I've always been a big fan of. In fact, I think I remember speaking about it at some EIC events in the past. That I was always fascinated by runtime access control from a governance perspective. From my time at SailPoint, how do you govern a real-time access where you can understand the policy and you can understand the inputs into it, and you can take some view of control or review of that. But to your point, I think it's just happening at machine speed now, which is interesting. I mean, I see a lot of people trying to, retrofit Rego kind of, loop-based policy languages, and I don't think they work. I think that Amazon's got the right idea with Cedar as a policy, something that's non-Turing complete, so as that it can run at embeddable speed. Because we're going to be making decisions here in microseconds that could potentially change the world. So how do you govern that? We're still trying to work out. How do you provide an auditor a path of assurance that the right things are happening? And you've got to look at the behavior, and you've got to close that loop very, very quickly. And it's like everything we ever learned about access in generation 1 has now got to happen in real time, right the way down to attribute source and provenance, policy evaluation, and control over the agent intent process.
Same quarter, same sources. Both are real. The jobs getting cut are mostly entry-level roles, manual QA, routine front-end work, middle management coordination layers, and content operations. Work that's either left over from pandemic overhiring or genuinely easy to partially automate. The jobs opening up are different. AI integration, ML ops, system architecture, security, cloud infrastructure. Roles where someone actually has to own what AI tools produce, not produce it themselves. If you try to understand tech as one unified market in 2026, you're going to get whiplash. If you understand it as two markets moving in opposite directions at the same time, everything clicks. Okay, so
sit down and listen. Class is not dismissed yet. Here's what's up. The AI-driven layoffs that happened recently are backfiring, and that is spectacular. 2 in 3 companies that made AI-driven layoffs in early 2026 are already rehiring those same roles. Get wrecked, Big Corp. You f***ing losers! They tried to replace us and failed miserably! F*** you! Nearly 1 in 3 companies said that rehiring ended up costing them more than they ever saved from the original cuts. Another 42% broke even. That means that 2/3 of these companies ran the whole godforsaken operation and came out with nothing. And yeah, that's awesome! There might be some hope after all. The AI is dog shit.
To get our latest episodes.
The conversation around AI and jobs is evolving. It's no longer just about AI replacing individual workers. More companies are starting to suggest that it could eliminate layers of management as well. Coinbase CEO Brian Armstrong announced plans to cut roughly 14% of staff last week, citing both market volatility and the speed at which AI is reshaping the business. PayPal made a similar move, saying it plans to reduce its workforce by 20% over the next 2 to 3 years because of AI. And perhaps the clearest expression of this new thinking came from Jack Dorsey, who said, quote, "Most companies using AI today are giving everyone a co-pilot, which makes the existing structure work slightly better without changing it. We're after something different, a company built as an intelligence with no need for a permanent middle management layer." So Scott, there's kind of a lot to this.
Inside the location. However, I'm adding one new thing, and this one alone is going to make a big difference. I'm adding the last 5 seconds of clip 1 as a reference video. That way, the second scene starts exactly where the first one ended. And now I'll paste in the prompt. Since this is the moment where the character pulls all the chips toward him, he becomes completely dominant and satisfied. So that's why I'm going to change his emotions one more time and then generate the video.
Gentlemen, it's been a pleasure.
And this is where the reference video feature really shows its value. The environment, lighting, and overall scene carry across both shots, so it feels like one continuous take rather than separate generations. Now for the third clip, the process is almost the same, but with a different
heavier, like a title reveal. Now there is one more thing to set up before clip 2 generates. Every new clip starts completely from scratch, unless you give it something to continue from. If clip 2 uses the same reference images as clip 1, the lighting might get changed a bit, and the character might not look exactly the same. Then, when you put them together in CapCut, they won't feel like they belong to the same scene. The change is to add a video reference for clip 2 along with the image references. After clip 1 is generated, I go to Upload Media, then Video Generations. I pick clip 1, trim the last 3 to 5 seconds, and use that trimmed part as the video reference for clip 2. And I leave the reference images and elements as they are. Let's go ahead and generate this now.
Then we found it. Buried. Silent. Waiting.
She is already standing at the base of the structure, looking tiny next to how tall it is. She slowly steps forward. Then we cut to a close shot of her gloved hand pressing flat against the surface. The moment her palm touches it, faint blue symbols light up and spread across the dark surface like a wave. The last shot is a close-up of her eyes inside the visor. Her eyes are wide with awe, and you can see the blue glow reflecting in the glass. The narrator's line is, "Then we found it, buried, silent, waiting." And it comes out exactly how I imagined.
Then we found it. Buried. Silent. Waiting.
The same video reference method will carry into clip 4 later, but clip 3 is where I break the chain on purpose. Clip 2 ends with a close-up of her eyes. Clip 3 starts with the structure exploding and the whole landscape going chaotic. That sudden shift from calm to intense is what makes it hit. So for clip 3, I only use image references and no video reference. And here is the full prompt that I used. So let's go ahead.
Instead of a random clip. Since our story is now set, there's one more thing we need to do before we start generating our animations. Before we generate a single video, we need to create all of our assets. And I want to be clear about why this step matters so much, because it's the part of the workflow that most people either rush through or skip entirely, and it is the reason their animations do not look consistent. When you create your assets like your characters, location, and objects before you start generating, you're giving the AI a fixed reference point for every clip. That way, every single character and the environment look the same in every shot. That consistency is what makes a series of AI clips feel like a single single, coherent animation rather than a collection of separate generations. To do this, we're using Higgsfield. If you didn't know, Higgsfield is an all-in-one AI platform that gives you access to every single thing you need to build a professional animation inside one place. Once you've logged in, you will see the main dashboard. The main section we need is Cinema Studio, which you will find at the top of the interface. So click on that. We have 4 assets to create: 2 characters, 1 location, and 1 object. Let's start with the characters. Make sure you are in image mode inside Cinema.
We went with this. Once we are done with this Spring AI, we'll focus on the ADK, the Google ADK. Now, if you want to create agents, this is a very good tool. So we'll understand the architecture of ADK. We'll understand different aspects here. How do you make agents? How do we do configuration? How do you create the workflow? How do we work with A2A protocol, which is agent-to-agent protocol, and of course, the deployment part of it. And we will do that on Google Cloud. And let's look at the alternative of LangChain, because if you are in the Python world, you might have heard about LangChain, doesn't matter in which domain you are. Now, since LangChain works with Python and it's a good tool, what about Java? In that case, we got LangChain for J. The creators of LangChain for J are not same as LangChain, but it's a very good implementation for Java, the LangChain part of it. In this also, we got different things here. It's a bit different from Spring AI, and we'll highlight those things when you are doing this course. Almost the same flow. The different would be we can work with the agents here, right? So we'll understand the agent workflow. How do you build agents here? And most important, the human in the loop. Now, if you're thinking AI is going to replace humans, not exactly.
We've got one more to look at: test coverage and quality analysis. And we're running this knowing that we don't have tests. But I just want to show how it works, what it looks for, and things like that. So we'll see you there. Okay, now we're at our final one. And testing, because testing is already last. We made this one last. And we actually don't have any testing going on in this application. We haven't built it yet. And that will be a part of this course, right? So right now, we are going to do an audit to analyze the testing, just so we can see what it's all about. And as a reminder, github.com/Jeremy Morgan, Cloud Code reviewing prompts if you want copies of all these prompts. Now it's thundering. I think it's been a different verb every time we've done it through this course, which is cool. So evaluate testing implementation for this software project. Analyze test coverage, test quality, test patterns, missing tests. You know, that's where we're really going to see it. But if this were a larger software development project, this is an important audit. This arguably one of the most important, if not the most important, because look at what we're checking for here. We're checking for test coverage. Do we have unit tests? How much of our code is covered by those unit tests? Do we have integration tests? Those are always tricky. Are they present? Are they functional? End-to-end testing, also extremely important. Do we have any end-to-end tests? Uncovered critical paths. So what does that mean? That means a path that a user could take through the software and get untested code. Guess where the problem will probably arise? In that path. Test quality. We want it named well. We want the arrange, act, assert pattern. We want test independence, meaning, this test shouldn't rely on another test to get it done. We want mock usage when it's appropriate. And we want to test data management. We'll test pyramid adherence, unit integration end to end, testing anti-patterns, implementation versus behavior, brittle test identification, and test speed issues. So, and then it's going to look for missing tests, which of course is what we have. Now it's already gone through. We're going to select yes. We're going to take a look at this. Report on our testing, or lack thereof. And this is the first time we've done an audit, and we got a 0 out of 10. So each of these audits, I ask to rate us on a scale of 1 to 10. We're at 0. So it says this Express login demo project currently has 0 test coverage. The application contains critical authentication functionality, but it lacks any testing infrastructure or test cases. So no unit tests for the component. Here are all the files with 0 test coverage. Integration test, non-existent. No database connection validations, no end-to-end flows, no middleware. End-to-end test coverage, non-existent. Here's what we're missing, a complete login flow.
Now you may ask, how can you actually use this feature? Well, early users that Claude have reported are using it to scale multiple concurrent Cloud Code sessions at once. This is by dispatching different ideas and workflows in parallel while returning later to fully completed pull requests ready for review. Now, I kind of doubt that because you all know Cloud Code limits are atrocious, and I don't know how this is going to help with that because you have multiple agents now running simultaneously that are going to eat up so many tokens. So I don't know how truthful this is, but regardless, if you do have the ability to pay for your own API and pay for tokens as you go, it is something that could be used for long running autonomous agents like PR babysitters, or you can have it for dashboard updaters. You can even use this new feature for looping background jobs with upcoming runtimes visible directly in the interface that we had showcased. And since you can quickly jump between sessions using simple and
So one way to mitigate this, and the most simple way, is by setting the termination conditions. So set up a max retries, or it could be max number of steps that the agent can take before it decides that it cannot find the answer for you. It could also be the max runtime usage. So that way, you're not stuck in this loop where you're wasting resources like compute and the API costs are going up. Secondly, you can also start doing the action tracking, where you actually look at the actions that the agent is taking, compare them with previous actions, and see if they're significantly different. If the search is similar across all the retries, then there's no point wasting your compute to search with the same criteria. So that can help you mitigate the infinite loop scenario. Progress tracking will ensure that you are getting better outcomes with each retry. So when you track progress, let's say in this example, you will know whether you're getting better results with a retry or not. So that way you can mitigate this infinite loop scenario if you're not getting better results with each retry. That is how you can mitigate infinite loop. Now, this is not a super serious failure mode, but it will lead to wastage of.
So taking a step back, we've started to form this picture of the different layers that we need to work in as we build a frontier memory system. We've talked about the storage layer, which is where the data is actually stored, what kind of metadata and attribution data we're leaving alongside of it. We've talked about the structure and the content layer. This is things like our decision to model files, memory as files in a file system, and earlier with skills as a form of procedural memory that have a pretty lightweight spec that say, hey, here's how you can actually learn how to do this new capability and equip yourself with new knowledge. And then there's the process layer. This is things like how often is memory actually updated? What triggers updates to that memory? And what sources does it use to decide what changes to make to memory and have new things to learn? And we think that agent memory, the API that we've been discussing, solves part of this. But as we started to scale this up into these more complex multi-agent systems, we also saw a bunch of limitations. We saw cases where sessions were kind of missing learnings that other agents and other sessions had already kind of figured out on their own. We saw these common mistakes and these shared patterns across multiple agents working in the same environment. And we also saw that they weren't super efficient at keeping up this large-scale memory store and keeping it up to date in a holistic and efficient way. They were kind of siloed into the specific task that they were working on. So for the past couple of months, we've been experimenting with a couple of different types of processes to kind of supplement this with. And we landed on one. We call this process Dreaming, and today we're launching this in research preview in the Managed Agents API. Dreaming is a process that looks for patterns and mistakes.
You're supposed to interact with ChatGPT's new main model. Shift it. Basically, instead of being super detailed, they now recommend you prompt for results. So what that exactly means and how the results differ from what you might have experienced last week. And also they claim that hallucinations were reduced by over 50%. Ooh, I'd like to hear that. That's what we're going to be looking at today.